Welcome to this explainer. Today, we're going to demystify the actual magic happening all around you every single day. I'm talking about the hidden forces and invisible rules that make our entire physical world work.
Let's kick things off with a little mystery right inside your fridge. Have you ever wondered why liquid milk suddenly transforms into thick, tangy yogurt?
Or think about the last time you looked up at a celebration. What makes fireworks burst into those brilliant reds, greens, and golds instead of just, standard fiery orange?
Or even something as simple as washing up after a long day. How in the world does a plain bar of soap completely strip away heavy grease and grime with just a quick splash of water?
Well, the answer to all of these everyday mysteries is chemistry. It's the study of what things are made of, their structural arrangement, and how they transform. Basically, it's the invisible rulebook governing everything. Literally everything, from the air we breathe to the lithium-ion batteries powering the very device you're using right now.
Here's a great little memory trick for you. At its core, CHEM equals change. The entire field is dedicated to understanding why things change, how they change, and the completely new states they assume. That is the true heart of what we call the central science. Section 1. Understanding matter, all around us. Now, before we can analyze change, we have to define the main character here, matter. By definition, matter is anything that has mass and occupies space. So whether it's the wood in your desk or your own physical body, if it takes up room and has weight, you are dealing with matter. All matter possesses specific characteristics, which we call properties. Take a simple glass of water, for instance. It's perfectly colorless, odorless, and tasteless. These physical properties basically serve as the ID card of a substance when it's just sitting there in its resting state. Then we have composition, which determines the actual ingredients of this matter. Let's say you're looking at a specific metal alloy. Breaking down its composition reveals it's exactly 70% iron, 20% carbon, and 10% nickel. It's the ultimate elemental breakdown, kind of like reading a recipe.
And then structure dictates how those exact ingredients are arranged. It's wild. Just as the exact same pile of bricks can build entirely different buildings, carbon atoms can arrange themselves into a brilliantly hard diamond or incredibly soft graphite. It's the exact same ingredients, but an entirely different structural geometry.
Section 2. The rules of change, matter transformations.
Okay, so matter undergoes two distinct types of transformations. Physical changes alter only the appearance. Think of ice melting. At the end of the day, it's still water. Chemical changes, however, like burning wood or rusting iron, form a completely new substance. The chemical bonds are actually broken and reformed, and you definitely can't simply unburn a log.
The foundational rule of all these transformations is that every single one involves an exchange of energy. It's a two-way street. It's either an absorption of energy, pulling heat in, like that ice melting in your hand, or an evolution of energy, releasing it outward, like burning wood giving off heat and light.
Section 3. Chemistry branches, specialized fields.
Because the scope of matter in our universe is just so unbelievably vast, chemistry is divided into specialized branches like organic, inorganic, analytical, and environmental. This specialization is absolutely crucial. It allows scientists to isolate specific variables, solve highly targeted problems, and develop brand new technologies.
Section 4. Physical Chemistry, Exploring Rules.
For the rest of this explainer, we're going to focus on physical chemistry. This branch studies exactly how substances behave by applying the strict laws of physics. It's really the science of why and how. Why does water boil at a specific temperature? How fast does it vaporize? And exactly how much thermal energy is required to make that happen. Physical chemistry zooms right into the micro level. It studies atoms, which are the smallest units of elements, and molecules. It strictly analyzes the behavior of matter during chemical reactions, tracking exactly how these tiny particles move around, interact, and exchange energy. Nature follows strict mathematical rules. By applying established physical laws like thermodynamics or the gas laws, scientists don't have to just guess. They can precisely predict how a chemical reaction will behave, its exact energy yield, and the reaction rate. It acts almost like a mathematical crystal ball for molecules. So why does this matter to us? Because predicting molecular behavior gives us immense power in the real world. By leveraging these physical laws, industrial processes are optimized to be faster, safer, and way cheaper. This single branch of science is directly responsible for the fertilizers that grow our food, life-saving medicines, and even the volatile fuels that launch rockets into space. As we wrap up this explainer, I want to leave you with this thought. The human body carries out millions of these chemical reactions every single second. Even the simple act of breathing is a complex chemical process governed by the strict laws of physics. So, knowing that you are, quite literally, a walking, breathing chemical reactor, what other daily miracles do you think are happening inside you right now?